Hello everyone, I welcome you all to this very small channel, and today we are going to learn about a very interesting and important topic of any competitive exams like GATE, IES and all the other state or the PSU level exams, so which is known as the surface tension. So in this video we will first of all know about the definition of surface tension, then we will see the mathematical expression for surface tension. We will also know about the surface energy, its formula, and finally we will see the most important thing, that is the different cases of surface tension from where the all the problems of all exams come. And directly we have to know only the formula to solve any kind of problems related to surface tension. So okay, first of all let's see about what the definition of surface tension. So simply, the free surface of liquid behaves like a stretched membrane, and it tries to minimize its area up to maximum possible extent. So from the Pascal's law we know that the pressure exerted inside a fluid is equal in all the direction. So let's say this is a point inside the fluid, this is the free surface of a liquid which is kept inside a tank or any water container. So if we consider this point B, we can see that the forces exerted from on this point is equal and opposite in all the direction. So ultimately all the forces are getting balanced and the summation of forces is equals to 0. But in case of the free surface it is not like that, because there is no forces acting on the upward side as there is no fluid, no liquid. So what happened in this point? Let's take the example of point P. In this point the forces are being acting on this side, but there is no force in the upward direction to balance the force. So ultimately what happened, uh, the the free surface of the liquid acts like a stretched membrane. So this phenomena is known as the surface tension. So if you want to know one example, one very simple example which will help you to understand this, is that uh, we sometimes see that very small insects floating on the water. So as we know that, for example, this is a water surface. Sometimes if we can see that any small insect like ants or something else floats on the water, although the density of that insect may be greater than the water, but still is floating on the water. That is just because of the surface tension. There is always a pull type nature of the free surface of the liquid, which is just um, pulling the water surface, which is acting like a stretched membrane. So due to that effect, sometimes we can see the small insects floats on the water. So this is the all theory. This is all about the surface tension. So now we will see that what is the mathematical expression of surface tension, what is its unit. Okay, so now if we talk about the mathematical expression of the surface tension, it is generally denoted by sigma, and it is given by force upon length. So we know that the unit of force is Newton and the unit of length is generally meter or centimeter. So the unit of surface tension is coming out to be Newton per meter. So you have to remember this. The unit of surface tension is Newton by meter, and the formula for surface tension is force upon length. Now what is surface energy? The work done in contracting the free surface. We have just talked about the behavior of the free surface like a stretched membrane. So the work done in contracting the free surface is nothing but the surface energy. Okay, so it's generally denoted by W. W represents the surface energy, and it is given by surface tension into area, which is W equals to sigma into area. So area here, the area of the free surface of the liquid. The free surface of the liquid is this, and the surface tension is denoted by, surface energy is denoted by surface tension into area. The unit of surface tension we know that Newton per meter, and the unit of area is meter square. So finally the energy, the unit of surface energy is coming out to be Newton meter. Okay, So you have to remember these two formula here, the unit and formula of surface tension and the unit of formula or of the surface energy. Now we will look into the very important things, that is the special cases of the surface tension. Okay, now if we talk about the surface tension in different cases, first of all let us take uh, the case of water droplet. For example, this is the water droplet. So inside the water droplet we know there is water, and outside the water droplet there is air. For example, the inside pressure of this water droplet is Pi, and let the outside pressure is P naught. So P will be the excess pressure, which will be equals to Pi minus P naught, as the inside pressure is higher than the outside pressure. So P is the excess pressure, which is equals to Pi minus P naught. Now this is the sectional view. If we cut this, so this is a cross sectional view of the water droplet. So here the excess pressure will be acts towards the center, which is P, and the surface tension is acting on the circumference of the cross section. So ultimately we know that the summation of force will be 0. So the excess pressure into the area of that cross section, which will be P into pi r square. So P into pi r square will be equals to the surface tension, which is acting in the surface, and as the surface tension is only acting in the circumference, so here the surface tension into the 2 pi r. So ultimately if we solve it, the final expression is coming out to be P equals to 2 sigma by r, which is the only important things we have to remember. We have to remember only the formula here. Whatever the question comes, it will be directly formula based. We have to simply find the value of the surface tension, or you will be said to find the value of the excess pressure. So this formula we have to remember only, that for water droplet the formula for excess pressure P equals to 2 sigma by r. And one more very important thing is, here the number of free surfaces equals to 1. What is the free surface? Free surface is that surface which separates two different fluids. For example, here the fluid inside was water and outside was air. Only one surface is there between these two different fluids. So it is therefore the number of free surface is 1. In the next case we will see there will be two free surface, so we will talk about that. So here in this case, this is the second case, soap bubble. So in case of soap bubble, what happen? Inside there is air, there is one surface which separates the inside air, and here it will be water. This middle surface will be water, and there is one more layer which separates this layer from the outside air. So total two layers is there. One layer is separating air from this water, and this outer layer is separating water from the outside air. So there is number of free surface will be equals to 2, and ultimately the final formula will be coming out to be excess pressure P equals to 4 sigma by r. This is also one of the very important formula. We have to also remember this, that in case of soap bubble there will be two free surface, and the formula is pressure equals to 4 sigma by r. And one more thing is there, which is the water jet. This is the third case, which is also very important. We have to only remember that in case of water jet, the excess pressure formula will be coming out to be sigma by r, and here also the number of free surface is equals to 1. So these three important formulas we have to keep in mind to remember or to solve any kind of problems coming out in exam.